उसका वॉल्यूम देखना या ये माइक दे देना.
Hello. Hey. Hey guys, how are you? Good. Response time is awesome.
Speaker यही है अभी. Nobody will backpitch.
तो बाहर जाओ थोड़ी देर.
Speaker को और.
So guys, I'm senior marketing engineer at Soda. So before getting into the talk, let's talk about what I do. Right? I have been working with the company for the last 3.5 years, and I'm mostly responsible for scaling their application, maintaining the kernel. So how many of you know what a workflow engine is? Workflow engine. No? So basically, workflow engine is a combination of two key components. One is a state, and the other is rules. So we have rules which can modify state of a workflow, and workflow is nothing but a process, right? So you can is a platform where you can come and configure any process that you feel like. For example, there was this time where getting a vaccination slot for the COVID vaccine was very difficult. So one of our analysts, not an engineer, they came to a platform, configured a process or a workflow where you would enter your Aadhaar number and it would directly pull the Arogya Setu APIs to get you a slot on your preferred team, right? So when you are working on such an application, there are a lot of challenges you have to face when scaling. So it's fundamentally it's a directed acyclic graph where nodes are communicating, and each node, if you go inside it, it's again a DAG, right? So end level, you're communicating data from bottom to top and then between the nodes, right? So this talk is going to be about what I learned over the years and how we benchmark our application, how we find bottlenecks. Honestly, this is the first rundown of this talk, so it's mostly going to be hands-on and whatever I've learned and whatever I've observed over the years, right? So how many of you know how to develop in Django? Have used Django framework? Okay. And how many of you have actually worked on optimization of Django? Cool. Okay. So what's your take? Let's say I give you a web page, right? And the customer is reporting that what's your web page what's slow? It's running very slow. How would you go and debug it? Anyone?
Number of requests. Number of queries.
Number of queries directly.
Lighthouse report.
Lighthouse report. How about looking at the network tab in the browser? Right? That's the first step you do. You go to the browser, open the network tab, see what's going wrong. Could be the user's internet, right? And then you see that there are certain APIs which are running slow, right? That's when you move to an APM or what you said, a reporting platform, which will tell you what's going on with your system. Now, when you look at that API, it could be just that API which is slow in itself, or it could be other things going in the background on your application which are making that API to work slowly, right? So we'll discover tools. We'll mostly discuss tools. I won't deep down into how and what to infer from the tools, but I'll talk about how to use those tools to identify bottlenecks in your application. Right? These are something that I use in my local environment mostly, but then at the end we discuss a case study on how you can do it in a production environment as well. So this will be divided into 3 sections. First is preparing the benchmarks. Now that you have identified that something is going wrong with your application, you need data to test that, to reproduce on your local, right? So first you prepare data for your benchmarking. Second, you actually run the benchmarks. Third is you analyze. Now, for preparing the benchmarks, how many of you are aware of fixtures? Fixtures, right? And how many of you are aware of factories? What is factory? What is a factory?
It's basically an emulation where you are able to plug your fixture so that you can eventually use it multiple places.
Right, and basically an interface for your tables and to generate that data. Right? Fixtures require you to manually put that data. For Django, you must be aware of the load data command. Right? Fixtures have a you write it in YAML or you write a JSON, and then you push that through load data, it gets into your model, and you have test data ready. Other way is to use factory, right? So there's a very easy to use package called Django Factory Bot. Right? You use Factory Bot, and what you can do is, okay. So before diving into this, let's go back, take a step back, and look at the application that we will be using for this talk. Right? Zoom.
font थोड़ा change.
Can somebody can you help me?
Command plus.
No, it's not working.
References में जाके find करें.
Forward to change the cover.
References help कर references.
Yeah, good enough. I can see. You look from the back.
So what I've created here is a demo bookstore. Right? A very simple application. There are books are authors, right? And then for books can belong to different publishing houses, right? So on top of that, we have introduced tags. Now what I want to demonstrate is how one-to-one relationships work, how foreign key relationships work, how many-to-many relationships work, and build a very generic application around a listing. Basically, it's just a list page. You go to a web page, you see a list of books. It says who was the author, who's the publishing house, and what are the tags against it. Then you can scale this to do search based on tags and show based on user preferences. You can add that to the user profile, right? Just go through the models, skim through it, and let me know once you guys are ready, and then we move on to the factories.
So how many people are not following anything? सब कुछ follow कर रहे हो?
That's not
Good to go ahead.
That's not the right question.
Ask how many people are following something.
Like it is okay to ask dumb questions.
Yes.
Yeah.
That's how you get smarter.
So now we were talking about factories. I'll just quickly open Django's. Let's see.
How many of you know what is Django? Everyone? Almost.
Right, so this is what Django's documentation says, how you load data. You create fixtures in YAML or basically JSON, run the load data command, it reads from a file, inserts it into your model. Other way to do is using factories, right? So if you look at factories are basically interfaces to your models. And here you have random generators. So factory has generators for different kinds of, I'll say entities. You can generate addresses, you can generate company names. Right? It has different generators for different use cases. Now I have configured factories for each of the model, right? And code link them similar to how my models have been created. So I'll just split this. Right. Now if you look at author has a foreign key to user, one-to-one to user. Similarly, author has a subfactory. Once you create an author, it will automatically create a user for you. Right. This can both be used for testing as an actual test case setups and for benchmarking. You can now write simple Python scripts on top of it. You don't need to worry about validation. You don't need to worry about creating that large JSON file. It will automatically generate the data for you. Right. Now, so along with this, I've written a management command which simply loads data into these models. Right. We are creating nothing but 5 publishers, 5 publishing houses, 10 authors, 10 tags, and 25 books corresponding to each publishing house. So 5 for each publishing house, and then I've randomly taken some tags. Right. Questions around this?
So like fixtures are basically used to add filler data
Right.
to do benchmarking.
Right. Fixtures or factories, either case. Fixtures are more of a manual effort. You have to put in your data. So let's say I ask you to give me 100 random books. Right? When you load fixtures, you'll have to sit down, create a JSON where you enter names, book 1, book 2, book 3, book 4. What here I've done is I've created an interface. I've said the name is a random word, any random word, it should be unique. And when I say books dot, let's say create batch of 5, so it will give me 5 books and automatically assign the names, authors, and create all the related models. I don't have to worry about data validation because I've put that. So factories directly link to the data validations of your models as well. Right? Whatever the foreign key relations are, whatever the unique constraints are, whatever the database requires, it will map to all of that and create data automatically based on that. So you don't have to worry about writing it manually. That's the beauty of it. And a very good use case of this is while writing test cases. Right? So if you have written test cases is nothing but given. What you are given, you cook the data. When you run the data, run it against the cases, and then is where you assert against the data that you have put. Right? You already know that 1 plus 3 will give you 4, so 1 plus 3 is your given. You run the sum function, you assert that you are getting 4. Right? Similarly, you can use factories to create that. It gets very easy when you are working on a large code base. Right? So now, once you have prepared the data, you have to run benchmarks. Now, if you talk about a production environment, it's getting thousands, millions of requests. How do you simulate that? How do you simulate that on your loop? Right? We have tools like Apache benchmarks. It comes pre-installed in macOS. I've already shared the link in the README of this repo. I'll share the repo with you guys as well. So Apache benchmarks basically allows you to simulate that behavior of receiving concurrent requests, 1,000 requests, 5,000 requests at a time. Right? What we'll do is I've created 2 endpoints. I've already coded this mostly. So I've created a simple view set which will allow you to list all the books. Right, let's run this and see what we're getting. Right. So it took about 10 to 15 seconds to load this book. What we have done is we are trying to put out everything about the book. The author, the publishing house, what are the tags, if author has a related user, what are the attributes of that user. I'll just make this a little larger. Right? So right now we have about, I'll say 100 something books, 100, 200 books in this API. And this is what I'll use to demonstrate a bottleneck in the system, right? I haven't created a full-fledged application. I just wanted to keep it simple so that everybody can grasp what's going on. Right? Let's look at the network tab. So first step, what we discussed was that we hit get. This books API is running, and it'll take about 15 seconds to get that data. Right? So if you can see, 7 seconds. Now if we go and look back at the view, I've used a simple serializer. Those who haven't coded in Django, I think it might be a little difficult to grasp what's going on here, but we have used nested serializer. So I pass a book object to the book serializer. What it will do, it will get the author, it will get the publishing house. The author serializer will get the user, and the tag serializer will get the tags for you. Right? It'll just serialize the data in JSON from your tables and send it back in a list view. Now, to run the benchmarks, let's say I use Apache load balancer, or not load balancer, sorry, Apache benchmarks. And with a concurrency of, let's say, 2 requests, I run 25 requests or 26 requests. Now, what we are doing is we are running our benchmarks here. We are going to make 26 requests where 2 requests at a time will run concurrently. You can change this behavior based on your application. Your application might be receiving thousands of concurrent requests, depends on how many servers you're having there. Right? While this runs, let's talk about.
I have a question. What do you mean by concurrent?
Concurrent means at the same time. You're receiving requests at the same time.
Concurrent requests.
Right? If you have, so a very good example of concurrent requests would be simple ATM transactions, right? ATM transaction doesn't allow you concurrent requests. If you are withdrawing and I am withdrawing, if the server receives 2 requests at the time, it will lock the account, serve one and then the second. But there can be applications which are ready to serve both at the same time. Right? So concurrency is not common in applications where you need atomicity, and it is common in applications where there is no atomicity. And how this is handled is usually you have multiple servers, so you have a load balancer. Behind the load balancer, you have multiple servers receiving the web app requests, which are serving to your client. So if you see here, we are receiving these requests. Now, while we are doing this, let's talk about what we are looking to analyze. Right? So once you have run the benchmarks, you have your data, you have your result. There could be multiple bottlenecks in your system. One could be a code performance issue. Right? Simple, very good example is a redundancy in the system, which can be solved with something like dynamic programming. Right? You have redundancy, and your program is computing the same thing again and again and again and again. You're wasting resources on, you're wasting your CPU resources on that computation. Right? That can, code performance can be analyzed simply with your time complexity, space complexity, and that we all know, right? We have all done enough of VSR2. Second is database performance. So database becomes a very key part of any web application, right? When you're looking at it, what usually happens is people have distributed their servers, right? You have 10 servers serving the web app request, then you have multiple async servers doing jobs in the background. But since you need to maintain, so for this example, we are using a Postgres database. Since you need to maintain the atomicity of your data, basically the asset properties, what you do is you have one single database serving to all these requests. Right? Now, based on the different processes in your application, this database can become easily overwhelmed. Right? If you have not written a query properly, right? It's an n+1 query problem. How many of you are familiar with n+1 query problem? Can you tell me?
Yeah, it's basically you have a model and then you have one-to-many relationship with another model. When you're fetching the model with and when you're fetching a model and then using the associated models, we Django is making additional queries to fetch the associated models. That's basically the n+1 query.
Right, right. So, in simple words, to get something which is related, you're making n queries, which could have been n additional queries to where n is the related object that you talked about, instead of one single query to get that data. Right? In this case, you're making your database work. Right? It's not about if that query is returning in the same time, but you're making your database work. Think about it. If your database would have billing for each SQL request that you make, would you not optimize? Right? In that case, you will, because once you start seeing applications at a scale, what happens is there are different, I'll say, non-trivial parts of a database that starts creating bottleneck. For example, database has a read buffer. A read buffer is nothing simply but when you are making a read request from a database, it gets the data from the disk into a kind of a cache and then serves it back to the wherever the client is, right, the server is. Now this can, if you have multiple connections to that database, this cache can get full really easy. Right now, if you are making heavy queries, repeated queries, which is bringing the data back from the disk to the cache, this can create a very easy bottleneck. Right, so you need to analyze your code, you need to analyze your database. Right, so third is server resource utilization. Could be a simple memory leak. You are creating dictionaries in your Python code, and it's creating, it's overflowing the memory. If anybody has used Celery here, Celery has an issue of memory leak. It's a very common problem with Celery. You have to restart the servers to free up that memory. Right? Third is any additional services that you're using. A cache, could be a cache, could be a third-party service which is creating bottlenecks in your system. Very common cases that you're integrating with a third party. You're making a request, but their APIs are returning in 40 seconds, 50 seconds, 60 seconds. Right? So you need to have right timeouts in your place for each request to understand if it will return back and if it clog your database, your application's performance. Right? Now to analyze this, what we have done is we use different tools. So, how many of you are aware of APM? What is your application process? APM?
Instana.
One day.
Right. You guys know what it is. So it's used to monitor the performance of a production application. Right. Similarly, we have something called Silk. Django Silk gives you a very handy decorator, or it's very easy to configure in your settings. So you just say, hey, I want to profile this particular API at this particular path, and whatever requests are made, he'll give you a detailed explanation of what functions were called, what was the path of the request, how many SQL queries were executed, how much time did it spend on executing the SQL, how much time did it spend on actually computing and getting results, right? So we ran a benchmark here, and now let's look at, so I've pre-installed Silk. I'm not going to go into how to set up Silk. The documentation is really very easy. I've set my views to be tracked, the list calls that we have made, now they'll be tracked in the Silk database. So if we go back here, Silk even gives you a very handy dashboard. What it does is it creates a table in your database and records all the requests that you have made and details of that in the database as well, and gives you a dashboard to analyze. Now we are looking at this, right? So, do you think this is a optimized view? It's making 1001 queries to fetch about 100, 200 books, right? And anybody who's familiar with Django, did you catch what went wrong when I showed the serializers? Let's go back here.
It's probably fetching.
It's N plus 1.
N plus 1, right? Right, so it's simply passing a book, and what it's doing is it's making a query to get the tags. Right? It's making a query to get the publishing house. It's making a query to get the author. It's making a query to get the user for each book that you're trying to fill. Now, how we look at this is I can go in and see what all sequels were executed, right? So it'll give me, see, you can see multiple times auth user is being called book. So auth user is nothing but the user model. So bookstore is being called, tags is being called. And you can actually look at the query, how much time it took, number of joins it did, and what was the plan. So who understands what a query plan is before we get that? What is a query plan for you?
So query plan in SQL in terms of RDBMS. So what happens is that when we write a query to fetch anything else, the SQL is behind the scenes create a plans so that like query will perform in optimized manner.
Right, so plan is nothing but a set of instructions to the database on how to execute, and it tells the database on how to actually act on the disk, get the data where it's stored, what kind of algorithms to use for searching, and that thing. So we are looking at this query plan. Analyzing a query plan is very simple. You have tools as well, but if you look at the query plan, it starts from bottom up, right? So first it did a index scan for bookstore in the unique ID of tags to get the tags, basically, right? Then it did a hash scan, sequence scan. So there are different types of scans that you can look at. Not going to go into the details of that. Any questions so far?
So Apache Bench you used, how is it different than JMeter?
One.
JMeter, Apache JMeter is there, right?
I'm not familiar.
JMeter is used for load testing.
Load testing.
Locust is also used for load
So
testing.
Locust is also there. So I just want to see how
I'm not familiar with either.
Then there is something called load.io.
I tried use Locust. So
yeah, Locust is good also.
Locust is good.
I have used. So I think it is similar.
Similar,
Yeah,
it's just generating requests and giving you control over concurrency and the number of requests.
just specific to a particular
Right.
endpoint when you're trying to do the Apache.
So I'm old school, right? Still.
So this was one thing that we looked at. So this was the performance of the APIs, number of queries made. Now you can actually analyze the database logs as well, right? So I've made some changes to my Postgres configuration to log the SQL queries, and so these were the logs generated. Let's look at one of them. There's a tool called PG Badger, and what PG Badger does is that it analyzes the logs and gives you a very easy to use.
Minus F for file. Oh. Yep.
I'll just restore an old file.
Yeah, it's okay.
Yeah, it ran.
It ran.
Okay. So what PG Badger does is it analyzes all the logs, what query was executed, how time it aggregates into, I'll say, readable reports which you can infer from on what went wrong and how is it. So let's say number queries by database, top queries. So see, I can filter by slowest individual queries, and I'll get what queries were executed and how long did they take, what are the number of. So what we are looking here is, we just run a single API, right? But in an actual working environment, there will be multiple processes, right? There will be a async task, your other APIs, which will be generating these requests on a single database. You analyze the logs and find bottlenecks into it. We'll get to a very good case study at the end of it, what we solved and where this can be used. right? So this is for analyzing your logs. And then you have something called SnakeWiz. SnakeWiz is a similar tool to Silk. What it does is, whatever profiling data has been generated here, you can generate a bar chart and a different type of report using that profile to analyze and see what functions were called, what went wrong, right? So that's that. Let's see what tools we have. Right. Now we have seen that it was making 1001 queries. Can anyone tell me how do we optimize it?
Select related.
What is select related?
So when we query something and the model has a related field, Django does a join.
Okay.
Django doesn't do a join. So
Are you sure?
No, I'm sure. When we access it, like after we did first query, then Django again queries the database.
Okay.
So if we want to get in a single query, we have to do a SQL join.
Okay.
So that is how select related will basically create a join in the query. In a single query, it will get us all the related fields.
Right. Anything other than that?
And there is
Prefetch. What is prefetch?
I don't know how exactly.
so if the join is very big, so it will take a lot of memory in that process.
Right.
So what we can do is instead of single join, we can ask Django to query multiple times.
Right.
So it will make a list of all the required IDs and it will query it from that table in a single query.
Perfect.
So I will explain to you. So it's more like a Django level optimization in which, let's say, you have a many-to-many. So in that particular thing, we have books. In books, we have many-to-many relationship tags, right? So it's going to be a possibility that 10, if you are listing 10 books, then 10 books are sharing some particular set of tags, right? So what prefetches does, so basically instead of every time for every book like making the request for the tags, is basically get a list, and then if it's get okay, then there are only unique 5 tags, then it's going to make 5 queries for getting the tags. So it can create a single list or then make a query.
Right. Instead of overloading your query with getting that duplicate information again and again, you're just making a Pythonic join to make a query and get that in a single query list, and then join in your application. So very simple difference between select related and prefetch related is prefetch related does a Pythonic join. It gets the data, joins it in your application server. Select related does a SQL join. It makes a join in the database and gets the data from there. Right? So prefetching, selecting, how many of you know what is deferring in Django? If I defer an attribute on query setter, I can do only. What are those attributes? If anybody has.
So deferred attributes basically when Django makes a query, if I have an attribute set as deferred, it will not include that attribute in that query.
Right. So here a very good example would be, let's say user has another. So we don't want username here, right? What we can do is we can defer this attribute, or we can tell the application to only get ID, first name, last name, and email. In this way, you are reducing the redundant data that you get. So the more data you get from a database, the more expensive your network call will be, right? Even if it's a matter of milliseconds, it actually, when you're scaling an application, those milliseconds will come back and move, right? You're wasting RAM on your application server to load that data. You're wasting your database resources to fetch that data and give it back to you. And then you're losing the time on the network call, right? On a small scale, it won't matter. But when you start scaling applications, they'll configure multiple requests. It will make a big difference. Almost. Right, so second view of this, right? Here I've used prefetch and select related, a combination of those. I'm prefetching the publishing houses, I'm prefetching the tags, right? I'm selecting the publishing houses, prefetching the tags. For author, I've used prefetch. It's a foreign key relation, so there's a common misconception in the Django developer community that prefetch can only be used for many-to-many. You cannot use it for foreign key, but you can, right? Like Sayam said, right? If an object is shared by multiple rows, it's better to prefetch instead of getting that data again and again. right? Prefetch can then be extended to further select the related entities to it. So, for example, user is related to an author, and when I'm prefetching the author, I'm telling it to select relate the user as well. So in a single query, it will get me everything. And let's run a quick benchmark for this. We'll reduce the number of requests to 4. See the difference, 1001 queries versus 3. And this is nothing, it's very simple, it's written in Django's documentation, but people miss it a lot, right? If you look back at the queries, it queried the bookstore ones, made a join on bookstore author ID. It prefetched related all the tags and the users, and then it queried for the publishing house. Right? This will substantially unclog your database. Look, just if you compare the time spent on queries, it's actually like scaled down by the use margin. Right? Questions? What we did here? What are you guys following?
So like I have a question. How does this prefetch and select query and work under the hood?
Work under the hood?
Right.
Select related makes a join, right? Select if you're telling something to if you're telling the Django's ORM to select related something, what it will do, it will make a SQL join and get that data in the SQL. So let's say book has an author, right? It will make a SQL join and return that data with the book itself instead of making another query. Prefetch. Okay.
So you've got two tables. You've got book and an author. So I think it's okay. So book and an author. Now book has some attributes, author has some attributes. If you just select on book, you're getting just those attributes with the book. You get an ID for the author. If you do select related, then attributes to the author will also be a part of the query that you're getting.
You can do book.author.name.
Other than
Yeah.
this, another scenario, if you do book.author.name, then another query is going to the database to get the name.
That would be the default case.
That will be the default case. If you do select related, then all of those attributes are in the RAM itself. You are not making a trip to the database again and again.
So like under the hood, like it uses some kind of algorithm like.
Join.
Joins. It's just okay.
See, it's making a simple inner join.
There are sometimes also you will see a performance decline in join.
Yeah.
But it will be performed by the subqueries. So you have to think of a way when you want to use the joins or something.
So it sounds very easy, like you think I'll do a select related and solve my problem. But it's not that when you're scaling it up. It's not by the book. It's never by the book, right? That's why these tools come in handy. You do it across. When you're benchmarking, you don't test for 10 requests. You don't test for 500 requests. You test for different batches, right? So what I usually do is I take two extremes. Let's say 10,000 requests and 10 requests, right? Then I come to the middle. I do 5,000. Then I come to the middle between that, and then I plot a graph, right? You'll easily get a graph. You'll see which is the sweet spot for your application, right? Select is working right now, but it'll start causing issues when you're scaling. It might start causing issues when you're scaling your application.
So you make kind of a flame graph.
Or it'll give you a bell curve, simple bell curve, and see where the most optimal part is. So another, I'll wrap this up with a bonus of this topic. How many of you know about caching a query? Right? Simple read queries can be cached. Has anybody thought one way is to select related and prefetch related? Other way is if you are making the same query again and again, right? Why not cache it? Why not use something that can save that query and not go to the database altogether? Right? This is where another very easy to use tool comes in, Django cache ops. You configure it, you tell which all methods to cache, which all models to cache, and it handles the invalidation. So the biggest challenge with cache is obviously invalidation. How do you know if something is streaming? Right? So it gives you all that packed into one place. You enable caching. For our use case, we are making read requests, right? And let's go back. So if I turn on caching, let's say make 1 minute. See, 0 queries. It actually cached everything because we are just reading from the
The first query should at least have initiated the queries, right? Because there was no, like, it would need to populate the cache.
Right. Let me check. It's in there. So we're getting the data. And
Validate the data.
let's clear this and
Yeah.
This will clear the cache also.
no, I'll have to do it.
That is CLI clear.
Mhm.
Where is it?
No sure.
Maybe it got stuck at the last one.
I think I didn't clear my cache earlier when I was testing this.
So the prep time.
So going back, so request 3 queries and then we hit it again. See, right?
Now it does.
This is earlier when I was testing that must be the cache. So this is a very easy use case. So where cache can be used frequently is the user one, right? Authentication में user details very seldom change. You make a profile which maintains the attributes of the user, but during the auth, most of the attributes of the user remains the same. So you can use caching on user if you have something which is very read intensive and which has let's say similar kind of filters, right? If a user will go back and see the same dashboard, like dashboards, right? Reports, you can cache those. So you can configure which models to cache and what are the timeouts, what are the ops, you can selectively cache here. And cache ops also provides you manual caching. So you can say, hey, cache this query. Or functional caching, you can cache a result of a function itself, right? All that is included in cache ops. Now coming to the case study.
So Puneet, how the invalidation will work?
Invalidation will work on chain. So you have installed the application, it's tracking these queries. It's when you're changing something, when you're updating something. In that part, invalidation, the cache invalidation will kick in and remove that from your Redis or whatever cache you use.
And one more thing, cache op doesn't work with selectivity, basically. So if you are joining a particular object and getting the data, then cache ops have an issue. Or you can say a constraint where it cannot invalidate the selected objects. So you have to think either you're going to use the cache ops or you can move your query to prefetch relative instead of selectivity to like have a harmony between the all systems. So your cache ops is like your major layer and then you can do the queries using prefetch.
So let's talk about a case study. I'll wrap up my talk after this. How many of you are familiar with sessions, like session management for a user, active sessions, right? So here's the use case. I want to keep my user's session active for 30 minutes from the last request. If he's making requests continuously, I want to increase that session's timeout, right? We had this implemented in our application, and looking at the APM, like how did we identify that there was a bottleneck? So we were just scanning through the APM for any outliers, and we saw that the session for a user was being stored like actually thousands of times. For each request, we are making that 30 minutes jump, right? You're saving, you make 50 requests from that user. Let's say you load a dashboard. That dashboard calls 20 APIs. So within a split second, you save the session 20 times, right? And plus, since you are updating the same object, you need to maintain atomicity as well. So you're locking it, and that slows down your request at the end. Marginally, but when you have an application which is at scale, so what we saw was there were about 2 to 3 million requests in a week for saving that session cache, and that boils down to 20,000, 30,000 users, and which is not efficient, right? So we use Datadog at our company. Datadog aggregated all those queries, we went in there, and one way to optimize that was we said, hey, instead of storing on each request, let the user be active for 5 minutes, we'll save it after that. If the user is active for 5 minutes, we'll increase by 30. If the user just made a request and he's coming back after 20 minutes, we can save that query. But if user just made the request and he's coming back after 2 seconds, we don't need to update the cache. We already know that he's going to be there for another 5 minutes or not. He might log out early or log in early, right? So these are the use cases, simple, different performance bottlenecks that you can find. Similarly, I talked about DAGs in the initial case study. DAGs, we have DAGs communicating data between each other. And consider a simple, forget about DAG, consider a simple parent node which has 4 children. Each child is communicating some data to the parent based on some rules, right? Now what was happening in our application earlier, which we were able to identify using the ETL tools, was that on change of data in any child, it was evaluating the rules for all 4, right? That was where we saw an increase in computation time as well as queries. So we optimized the queries, we use simple dynamic programming to store the state of the children and see which child has a valid state for using the old value. Right? So these are the different use cases that you can have around a Django application. That's all from us.